Hi my friends, let's model the part number 73 pipe right connector from my collection of 100 parts. The picture of this object is this one. It has an external thread and the drawing will show us more. External of gaze 2 inches and gas 3-4 inches. These are pipe threads and we discussed about them in my previous tutorials. Let's start with creating this object, this feature, by using sweep. The problem is that here we have a revolving feature. We cannot do like this one by extruding a circle. We have to create a revolve, and the problem is with internal hollow parts. This is why we'll adopt a special strategy. Let's start the steering curve is one with lines and arcs. 160 minus 60 is the first line. Next is an arc with the radius 60. And then a horizontal of 184 minus 60. Radius 60. Finish sketch, F6. These are dimensions. 160 minus radius, 148 minus radius for vertical and horizontal segments. The subject for the sweep will be this diameter, a circle with 72 diameter. This is part of our strategy. A new sketch and this plane, circle from the center point of 72. Finish sketch, sweep. This is the steering curve and we don't have any message. Yes, why? Because the circle was not empty with another circle. You know about the message. I presented to you in my former tutorials. Now I create this revolving, yes, this is revolving feature with these diameters. But first we have to know what is the external diameter here to apply a thread on it. To do this, we activate a Excel file. As in the tutorials presented on the screen, where you can find other details, we activate BSP pipe threads, and we look to case 2. The external diameter, external major diameter, is 59.614. We copy this. We don't save, never will save this file. And now we have in the clipboard this dimension. Yes? Then let's go back to creating a sketch in this plane, F7, with a contour, this contour, close, which is this, yes, to the middle, 46, 56, the diameter for thread, and 22 for the moment. Distance from the center point of 46. Then we apply constraint of this line to contain the center point. Then we change this line to be center line to apply dimensions. This is the thread, yes? And we apply paste. Yes. Good. This is 50, 56, 22, and 80 from the end. 80. I'll create also the internal contour, this with dimensions of 42, 50 and 3, but we don't use it for the moment. We'll use in the future in this tutorial. So internal is 42, and 3. Finish sketch. Revolve, join, yes, this external contour with its center line as axis. Okay, F6. You see the result, yes? A solid object without any hollow. Now we can create hollows by starting with a circle on the bottom with a diameter of 60. This hollow will be the next. Circle 60, finished sketch. Now a special operation, this steering curve to be shared. You see, the same sketch is in both places in the browser. They are not different. They are the same, absolutely the same. You cannot change this, and the intention to change only this. You cannot change a shared sketch after all. Good. We apply now sweep by selecting this internal area and the same steering curve like before, but applying cut, not join. Okay. You see the result. Very nice. Now we make not visible the shared sketch, and we make visible the other one, this one. We apply share sketch and it becomes visible, so that we can apply revolve on the internal contour. Yes, this one, the same axis, and cut. Okay, hide. Let's hide the shared sketch, and everything is very nice. Yes. Next are the flanges. You see there are two flanges. They seem to be similar, but they are not similar, they are identical. Look to these dimensions and to this. Radius 42, radius 20, distance of 120. We wonder if we can use this thing, and the extrusion is the same, 10 to this and also 10 to the other. We wonder if we can use this observation. Let's see. First is the sketch. The sketch is placed on this plane. Radius of 42. A circle with a radius of 20. And another circle. They are equal. Same horizontal, this is horizontal, of the two circles, and also one of them with a center point. Now I turn back the sketch, you'll see why. F7. We have here all the necessary data, geometrical data, and we create a tangent, the mark. When you don't see tangency mark, you have to place it manually. Trim, equal, very important to be symmetrical, equal these two tangents, and split. To make this and this, a construction line. And now the dimension of 120 is white, is fully constrained. Finish sketch, extrude this the other direction, join 10 millimeters, OK. Next I create a sketch to obtain points, and then I apply the hole and I select not through, because through means through the part, but to this face, and the other is here. Okay, now we have this feature created. Actually there are two features. I select both, copy, and then I select this face and I apply paste. The angle is not good, yes, you see. So I apply 90 degrees here, and I need to reselect the face. Finish. This is the copied feature. You have to be careful to create a sketch from the bottom and also the holes from the bottom, not from up. Try for yourself to see what happens, because I lost 1 hour of my life to find out. Yes, for you, be sure. Next is this feature, which can be created with extrude, not like this one, when we needed to apply revolve. The plane is 70 from the axis and the diameter is 36. The plane is this 70. Okay, and a circle with a diameter of 50, placed on the same. This is the same unbearable plane. Yes, I have to rotate this to be real. This is horizontal. Yes, because Z is always vertical. This is why. The distance is 80. Okay, dimension 80. Okay, finish sketch, F6. This is not useful at all. And now we have to apply a hole here. The hole is gas 3/4 of an inch, but this time we don't need to consult the Excel data file for pipe threads, because we can find the diameter by tapping. Look at me. this center threaded iso pipe threads, one half, and I go to the next. This is 5/8. Go to the next. This is 3/4 of an inch. Yes. The other dimensions of the same hole are 25. The diameter, the length of the thread, 25, and we have to select the face for finishing or ending the hole. This is okay. You see 25, and the hole must be not through, of course. You see here the result. Yes. Okay. All we need to add are some cuts to both here and here, and then fillets, of course. You see, this is 66 by 3, and the same is here. F6, XY, F7, and a rectangle, a very small rectangle here. I project geometry, the y-axis as a center line, y-axis, no more center line, and dimensions. This is 3, and the diameter is 66. Okay, this is not defined, as you can see. Yes, I can move. Why? Necessary to project this geometry, the generator, and to place it collinear. Now all the sides are white. Good. Finish sketch, revolve, cut, and that's all. And now the other. We select the plane XY, F7, we project geometry, this, and the generator. A line from the midpoint to this, an axis, a center line, to be equal with this one, to have fully constrained all the time here. And now we draw the rectangle. The distance is 3 and the other is 66, as we know. Finish sketch, revolve, cut, okay. You can try for yourself to apply the previous procedure to copy the last feature, and not this one, to place it on the other end of the pipe. Just try this. For the moment, we have to place here a thread, yes, of 2 inches thread. This face, not ANSI, not ISO, but ISO pipe threads. You see, because we delivered the proper diameter, Inventor recognized the gas 2 inches. Not 22, but all the way. Okay. There is a chamfer here of 2 millimeters. This is by default. And the others are fillets. Radius 4 is everywhere. Yes? All over this part is radius 4. This is simple. We can apply immediately, but only to place the proper value. Okay, material is as always steel cast, general aspect steel cast. Oh, there is another fillet here, yes, not 4 but 2 millimeters. Let's apply fillet of 2. Okay, some faces to be machined. Still polished. Properties, properties, physical update, 4 kilograms and a quarter. Good. That's all for today. Thanks for watching. Bye bye.